So today I'm talking about using RethinkDB with Jupyter. So the name Jupyter here, you might notice the spelling isn't like what you would expect if you're talking about the planet. The PY there is kind of a play on Python, which is what Jupyter is built with. So Jupyter, as I'll explain, is just a really incredible platform for interactive data science. And I've been using it with RethinkDB to perform, computations and crunch numbers and stuff like that. It's a pretty compelling pair, and I kind of want to show you today what it's like to use the two of them together. Christina already introduced me, but I'm Ryan Paul. I'm a RethinkDB developer evangelist. My Twitter handle is segfault if you want to follow me, with a PH there. So first I'm going to talk a little bit about Jupyter, introduce Jupyter project. In the beginning, there was the REPL, and REPL stands for Read, Eval, Print, and Loop. So for those who are unfamiliar, REPL is just kind of a console-like interface to work with a dynamic programming language. You can interactively type in expressions, and they'll know those expressions will be evaluated, and the results will be displayed to you. REPLs, they kind of I guess date back to the Lisp era, but they're a common feature of most contemporary dynamic programming languages. The nice thing about a REPL is it just gives you this incredible immediate feedback when you're working with data or dynamic values. So the REPL is a really great tool, and there was a project called IPython that sought to kind of enhance the whole Python REPL experience. So Jupyter has its origins in this project called IPython, which produced this really great interactive Python REPL with a lot of advanced features and convenience mechanisms that simplified interactive Python hacking, if you will. So the IPython REPL, like you can see in the screenshot, you basically type in Python expressions and it gives you the answer, and it has some some nice features like syntax highlighting and history management and quick access to shell commands and a bunch of other really cool things. So IPython was a great tool, but as it kind of evolved, they started bringing in more and more like richness to the presentation and the interactivity, and it evolved into something quite different. They created this thing called the IPython Notebook, and the notebook, it's sort of like a REPL, but it does much more. It gives you data persistence. So it's like an interactive environment where you can type in code and you can get the return value of the code, but then you can save all of the output of your session and intersperse it with other data and go back and modify it, and it turns into almost like a document, like this this really rich, interactive, reproducible, shareable history of your Python REPL session. And on top of that, you can embed rich media. So for example, you can have pictures. So if you're working with data and you have data that you want to visualize, you can use graphing library and have it display a graph inline. So in this screenshot here, it's a little small, but what you can see is that they've plotted something, and they're using matplotlib, which is a popular Python plotting library. And matplotlib has this theme where you can make it look like a XKCD comic. So that's why the little graph in the example there looks like something that you'd see on XKCD. So Jupyter, basically emerged from this IPython Notebook project. This is really rich. On the one hand, they have this really rich interactive REPL, which is their the normal REPL experience where you type in expressions and you get your results. And they have a terminal front end, so you can use it in your command line terminal. And then they have desktop GUI front ends, there's one that's built with Qt, the Qt GUI framework, which is really nice. So then on the other hand, there's also this REPL notebook that can evaluate code and save the results. So those are the two parts of the Jupyter project that have emerged from IPython. And so part of why they renamed it to Jupyter is because they kind of wanted to evolve past this Python specific kind of environment. It's still all built with Python. They're using Tornado for the notebook and various Python frameworks, but they kind of abstracted out this interactive REPL platform bit, and they made it so that you can use it with all kinds of different programming languages. So IPython now refers to just the Python part of it, like the specific, what they call the kernel that allows you to use Python with it interactively. And they use the name Jupyter to describe the overall project, which is the REPL and the notebook, which can now be used with multiple programming languages. So they've added support for quite a few, like if you want to use it with Ruby or R or JavaScript or what have you, you can actually do like a Jupyter Notebook with those languages. And it's just a matter of installing the necessary dependencies. So it's become quite an impressive project, and you can use it in a lot of ways. And they have, like a lot of community support from various interesting places. People contributing to it and helping to fund the project. And so when you use the notebook, you get like this almost like a literate programming environment. So for those who aren't familiar with literate programming, the idea is that you're creating like a document where text is the first class object and you're interspersing code in that text. And Jupyter notebooks are just fantastic for that kind of thing, that kind of literate programming. It's almost like a word processor for literate programming, because you can create like markdown and rich text documents that you're combining with these code snippets, and then you can have all kinds of other content generated by the code that's embedded inline, like visualizations. So Jupyter Notebook, like, it really lets you do a lot. So now, consuming RethinkDB data in Jupyter, Jupyter by itself, if you're doing like data science, you can do a lot of rich programming. Like, you can use like scientific Python stuff, and like there's a lot of like numerical and scientific libraries that are very easily accessible in Python, and it works well with all those. But here's the wrinkle: is that if you're working with a lot of complex data, then you're probably going to be storing it somewhere. You're not going to want to like copy and paste like these blobs of like Python dictionaries or whatever into your notebook. And so this is where RethinkDB comes in. I found it to be pretty powerful to be able to just take a database table, suck some of that data into a notebook, and manipulate it interactively in the notebook. And RethinkDB itself also has some really powerful built-in tools for data processing that align well with the kinds of tasks that you want to be able to do with Jupyter. So RethinkDB, this is a RethinkDB meetup, so I hope most people here have heard of us before, but briefly, it's an open source database for building real-time web applications, and it's a NoSQL database. Everything is stored as JSON documents, and it's a distributed database that's easy to scale. So in RethinkDB, our query language is called ReQL. And the ReQL query language, it really pairs nicely with Jupyter. One of the advantages of ReQL is it's designed to integrate with the syntax of the underlying language. So unlike like a SQL database where you're concatenating strings and trying to interpolate values into those strings, ReQL, you write ReQL expressions in the actual programming language that you're using to build your applications. So in a Python-based Jupyter notebook, you can write your ReQL expressions in Python. So it feels very natural and very native in Jupyter. So like as I said earlier, ReQL is also very expressive. It provides useful tools for data manipulation. You can do a lot of data slicing and dicing with ReQL. And I find that there's some things that are easier with ReQL, there's some things that are easier with Python. And in a Jupyter notebook, you kind of get the best of both worlds. You can use them both together in a really seamless, interactive way. So let's talk briefly about the Data Explorer that comes with RethinkDB. In RethinkDB, we have this administrative tool, let me make that bigger, that we call the Data Explorer, that's just built into the database. And in the Data Explorer, you can type queries and get the results. So this is great, but there are some limitations. And when you're working in a Jupyter notebook, it allows you to kind of obviate some of those limitations. So I'll show you now like an example of what I'm talking about. I'm going to do a query here. In ReQL, we have this RHTTP command that lets you pull data from a remote source. So I'm going to pull some data from Reddit. And I'm going to pull just the records from this subreddit called Cats Sitting Down, which, as the name describes, it's just basically pictures of cats that are sitting. So you see, you can just grab this JSON data from Reddit, and now we're gonna do some slicing and dicing on this here. Let's see, data, children, data. Then let's order by score. So we're going to order the we're going to rank in descending order from highest score to lowest score. Then we can pluck the score, the title, and the URL. So let's just see that. So okay, so see how we've got our records here. Okay, now let's take that a step further. We're going to grab just the URL, and we're going to filter for the ones that have JPEGs. Here's that list of JPEGs from this subreddit, and you see all I'm getting out of the RethinkDB Data Explorer is this array of URLs, and I can click on one of those links, and it'll show me the picture. See, there's the cat sitting, but it kind of bums me out that all you're getting is this array of URLs. Like, I want to be able to see my cats inline. This is like, to me, is like the biggest limitation of the RethinkDB Data Explorer. You don't get to see your kitties. So now I'm going to show you what this looks like in Jupyter. We're going to create a new Jupyter Notebook, and I'm going to paste in some boilerplate here just to get things moving along. Okay, now I'm going to do a similar query, like the Python equivalent to the same query. Okay, so we have this query. Now we're going to run it. Yep. Okay, so now you see we performed the query. It gave us the output. Again, we're getting an array of URLs. Now let's say that we actually want to display those inline. Let's do some Jupyter magic. And here we go. Now we have all of these cats sitting down, and see that it displays them inline as the result, as the output. That's really cute. Okay, so what I did here, this display an image, I'll explain that momentarily, but this is really the beauty of Jupyter, like this kind of like rich output. It gives you some superpowers. It makes it so you can see your kitties. Yeah, so I'll get into this real quick. The display and image, these are basically functions that are exposed by the Jupyter APIs. So I'll get into that in a minute here. Let me kind of switch gears. One of the nice features of Jupyter is that you can add special commands that work in both the REPL and the notebook. When you've got these special commands, they're typically prefixed with a %sign. So you can add these commands that do like programmatic transformations on the query. So when you type in your expression in the REPL and you put this %sign whatever command before it, the code that handles that can take the input that you provided, the expression, the Python expression, and it can mutate it or do whatever it wants with it. Like some metaprogramming in order to give you like a specific effect or operation. So it's a little bit abstract, but I'll show you a concrete example of this. So this is the actual REPL, and the REPL and the notebook are largely built on the same underlying engine, so the behavior is very similar. So I've added this special feature where you type %r, and then you can give it an arbitrary ReQL query, and it'll just execute the query and give you like pretty printed JSON output. So the %r, I've got this special handler that I've implemented where it's taking the rest of the line and it's saying, okay, this is a ReQL query. Now here's how you execute it, and then here's how you pretty print the output. So this is a nice way like to just do like quick ReQL expressions at the REPL without having to like set up a connection and manually perform the connection, or the query on a specific connection. Like, you don't have to deal with the connection handling. It gives you this like data explorer kind of experience. So that's pretty cool, right? Like, just quick, easy way to work with data. You can see here the data set I'm working with. I have the members of the Fellowship of the Ring from Tolkien's book. So, let's say you wanted to change all of the hobbits to, I don't know, like halflings. Table fellowship, filter, species, hobbit. So here we can filter for just the hobbits. Then if we wanted to change them to halflings, we could do update halfling, and then see we've got 4 that's replaced. But you see how it gives you this nice like syntax highlighting on your queries and all of that. So like there's some nice things that you can do with the Jupyter REPL. So I'll show you now how I implemented this %R. Basically, you're going to use the IPython APIs, and they call it literally a magic function. So you're importing this register line magic function that's kind of like that you kind of use as a decorator. So you see register line magic above the method. And when you use that as a decorator, it makes it so that % whatever in front of the name of the method will treat it as a magic function. So inside of the function, what we're doing here is we're importing the RethinkDB library. We're setting up the connection. Then we're evaluating the query and running it against that connection. And then we're doing a little bit of handling on the output. You see the in RethinkDB, if you, like, for example, query a table or something where there's potentially going to be a lot of rows, it gives you a cursor instead of the whole response. And what we're doing here is just checking to see if it's a cursor, in which case we just convert it to an array. And then I do the two pretty JSON. I don't need to show you guys how that's implemented, but it just basically pretty prints the JSON. I have another variant of this that uses Pigments, the syntax highlighting library, so that it will actually syntax highlight the JSON for you. But yeah, so you can see there's not a lot to it. Like, this is all the code that you need to create that magic function that allows you to do the %R. So I mean, that's one way that I've made it easier to integrate RethinkDB with Jupyter. So I'll show you now that this works when you build something out like that, like the magic function, you put it in your Jupyter configuration. It works in both the console and the notebook. So now I'll show you here just real quick. R.table fellowship. There you go. And see, the syntax highlighting works here. But yeah, you can see I used the same %R, and it gave me that shortcut for executing the query. And you can see that because we're pulling the records directly from the database, the hobbits are all halflings because we updated that. Jupyter provides APIs for displaying rich content. You can embed various kinds of things. You can take arbitrary HTML and embed it, have it be the output. So for example, you could create a magic function that takes and transforms whatever your output is of the expression into a HTML representation that looks really clean and nice. You can put in images, as I showed you, and that's all done by importing from this IPython.display. From IPython display, import image and display. So the display function is just basically a shorthand for saying take any rich dynamic object that we want to display inline and display it inline. And then there are various types. The image is the image class here is just a way to instantiate an image that we want to be able to display inline. So what I did when I wanted to take the output of that query and transform it from an array of URLs and make it show actual cats, I did a Python list comprehension. So we're iterating over each of those URLs, and for each URL, we're instantiating an image, and we're wrapping it in that display method. We're calling display on it. The image class, you can give it a file path, you can give it a URL, whatever. It'll just figure out what it is and load the image. So that's all you need to do in order to get it to display these images inline. How you display an image, you could just take the URL, wrap it in that image class, and then use the display function. Okay, so I want to get into some actual data visualizations now, because the title of the talk was data science, and as much as I like cats don't really constitute data science. So let's try an actual non-trivial example. We're going to use matplotlib, which again is a Python graphing library. So you can see here that matplotlib has this magic function, matplotlib inline. What that'll do is it'll tell it that whenever you display a visualization, it should show it inline in your notebook or your REPL. And this query, there's just a RethinkDB query here where we're pulling data from a table that has information about earthquakes that have happened in the last month. So I can actually show you real quick where that data is being sucked in from. The USGS publishes a feed. You can see here using RHTTP, I'm pulling in this USGS earthquake feed, and it has coordinates of the earthquakes and data about them. You can see here I have this like notebook document where I've got this rich text with links and everything, and I've interspersed the code with it that talks about geospatial queries here. So I've created an earthquake table, and then I do this query that fetches the records and does a little slicing and dicing on it in order to clean up some of the properties, and then inserts them into a table. What I've done here is I've created an actual RethinkDB timestamp because their dates were in the Unix epoch format, so I just parsed those. And then what I've done here with this geometry property is I've taken their geographic location information, the latitude and longitude coordinates that they provide, and I turn them into an actual geospatial point. RethinkDB natively supports geospatial points, and you can create a geospatial index on them, so you can do queries against locations. So that's what I did when I inserted the data into the database. So that's where the data is coming from. And now when you've got this data in the database, you can do some pretty interesting queries. What this one is showing here is a get intersecting query. I'm taking and creating a circle that's 200-mile radius from Tokyo, and I'm finding all of the quakes that line up with that, and there are a certain number of them. But anyway, to get back to the example, what I wanted to do was plot how many earthquakes per day over a 1-month period, and I want to show that as a bar graph. So first I filter to find the earthquakes from the current month, and then I group them by day, and then I order the groups so that each bar in the bar graph is another sequential day in the month. And then I'm separating out the values so that I have my x and y axes in separate arrays. So matplotlib makes it really easy to take that data and turn it into a graph. You can see at the bottom pyplot.bar, and then all I have to do is pass it an array with the x-axis and an array with the y-axis, and or whatever, and it's just like it gives you your bar graph. And then you do pyplot.show. Now normally if you were typing this into a REPL and you did pyplot.show, matplotlib would pop up like a little GUI window with your graph embedded in it as an image. But because we've called matplotlib inline at the top, it's going to show up inline in the notebook. So let's do this now. I've got the example down here. We're going to pull in that data and display it as a graph. So here I just executed that block, and you see how it displays the graph? So you can do inline graphing, and it's very easy. You don't really have to think much or do much setup. And I find this pretty cool. It's actually in some ways like easier than dealing with Excel. You can also do some pretty cool interactive stuff. So for my next example, I want to show you how to inject a map, like an interactive map, directly into the notebook. So again, we're doing this with matplotlib, but we're using a library called MPL Leaflet. And what that does is it takes advantage of a popular web library called Leaflet that's often used for embedded maps. And it kind of bolts it onto the side of matplotlib so that you can do like geospatial visualizations with matplotlib in a way that's very clean and interactive. Okay, so again, we have our matplotlib inline magic function invoked at the beginning, and then we import all of our libraries. And then we have the simple ReQL query where we are finding all of the earthquakes that are within a 200-mile radius of Tokyo. I think I showed you that query earlier. So we're taking that same query here, and then we're plotting it. So now at the bottom, you can see just a few, like a pair of Python list comprehensions where I'm pulling out the properties in order to feed them into matplotlib. And then once I've established the those values there and pass them in the latitude and longitude coordinates, I can do mpl leaflet.display, and it's going to show me my map inline. Now I want to show you what this looks like in the notebook so you can actually see the output. It's very cool. Okay, so you can see here that it loaded a map and it created these points, these little red squares that represent all of the earthquakes. But now watch this. Oop, sorry. Okay, you can zoom in, you can pan, you can click them, and I mean there are things you can do. You can make it so that things pop up when you click them or whatever. But you see, you get like this actual interactive bit that's embedded here that you can manipulate in various ways, and that's very powerful. Like this is just like arbitrary code. You can make your own visualizations and presentation mechanisms that embed whatever HTML and JavaScript you want. So I mean, you can create, really any kind of interactive visualization. So just wanted to put the links up here so you got additional resources. RethinkDB.com. It's where you can find RethinkDB. We're very easy to install, and our friends at Compose, who presented earlier, provide RethinkDB hosting if you don't want to host it yourself.